Hey everyone, Professor Lamar here, and welcome to video 2 in our 7-part series for Chapter 8. Now, for this video, we're going to talk about our first different type of experimental design, and that is a post-test only design. So keep in mind again that the first 3 designs we talk about, post-test only, pre-test, post-test, and Solomon foregroup, should be kind of kept together in one category when you think about these designs and go back and study. Now let's talk about what a post-test only design is. Remember again, a post-test only design is a basic experiment. So there's just one independent variable and one dependent variable. And when we do a post-test only design, this is exactly like what it sounds like. We have to first take a group of participants and split them up into 2 different groups. Now these groups have to be equivalent, which means that they should be comparable from one group to the next. We don't want, for instance, people with like a certain characteristic to all be in one group so that they're not accurately represented across both groups. But we want to make sure that there's similar people across both of our groups, and each group has a lot of diversity or different people in there. Now, what that means is our groups are comparable if there's a lot of people in each group and the groups are not significantly different from one another. And that means that our groups are equivalent. Now, once we obtain equivalent groups, which we'll talk about how to do in a second, we introduce the IV. And then after the groups have experienced the level of the IV that they received, we'll then introduce the DV and measure the effect of the independent variable on the dependent variable. Now this is what it can look like. We have our group of participants right here, and we randomly assign them to be in either the experimental group, like the treatment group, or the control group. Now let's first talk about getting that equivalency in our groups though. The principle of random assignment helps us achieve equivalent groups because this big group of participants here, no one is more or less likely to be placed in one group relative to another. They're assigned basically at random, so everyone has an equal chance of being in one group as they do another group. The principle of random assignment, again, helps us establish equivalent groups, which is really cool. If we let people self-select and choose if they want to be in the experimental condition or in the control group, then that could introduce a confounding variable because those who choose the experiment might have a different characteristic or might be different in some way for those who would choose the control group. The principle of random assignment helps us eliminate those confounding variables that our participants could bring to the table because it means that all of these participants are just as likely to be in one group as another. So random assignment is really great because it helps us achieve equivalency. And then after this, we introduce the independent variable. Now, in a basic design, if we just have 2 levels to the IV, we could have an experimental group and a control group. And then after that, we introduce the DV and we measure the effects of the IV on the DV. Now, if the independent variable has an effect, those who were in the experimental group should score differently on the dependent variable than those who were in the control. And the reason why is because, well, if the IV affects the DV, then those who get the experiment should score differently on the DV than those who are in the control. Now, to kind of bring this home to an example we've been talking about, maybe, for instance, we think that coffee consumption is related to happiness. So here in our experimental group, we have people drink 2 cups of coffee. And in the control group, we have participants not drink any coffee at all. They drink 0 cups. Then after the experimental group has had their coffee, we ask both groups to take a happiness survey. And we see if those who drink coffee are happier than those who didn't drink coffee. It's a basic experiment, post-test only design. Now I want you to pause the video here and take some time to design your own basic experiment, post-test only design, with the variables of sleep and happiness. Take a couple of minutes to think of how you would design a study that follows this format with an experimental group and a control group, working with the independent variable sleep and the dependent variable happiness. All right. Now, hopefully we paused the video. We took some time to think about what that could look like. And to kind of help walk us through it, let's do a quick example together that I thought of. Let's say we have a group of 100 participants. We randomly assign half of them to sleep 2 hours a night and half to sleep 8 hours a night. Now 2 hours is our experimental group, and it's called to the experimental group in this case because a lot of people don't sleep just 2 hours a night. It's recommended to get 8 hours of sleep, and so that's going to be our control condition. This independent variable sleep in this case just has 2 levels, 2 hours and 8 hours. And then after people sleep 2 hours or 8 hours, we bring them into the lab the next day and we give them a happiness survey to see if sleep affects happiness. Now that's just one of the things that you could have developed for your own post-test only design. And this was actually a super quick video that brings us to the end of understanding what a post-test only design is all about. In the third video, we'll talk about the next type of design, which is a pre-test post-test. But what we're going to do is actually pause the video here. Let's see. Oh, some technical difficulties. Oh no. Okay, so what we're going to do is actually stop the video here. This brings us to the end of video 2, and I will see you all for video 3. Bye.